If you came into Java anytime prior to Java 8, then interfaces were always composed of abstract methods only and instance methods only. You couldn't have anything static in an interface, although you could have constants. So you could have a static final property, but that was actually fairly rare. Instead, interfaces were merely collections of abstract methods that classes would implement in general. In Java 8, they have added two new features to interfaces, both static methods and default methods in an interface. Now, the interesting part about static methods is, remember, a static means class level in this sense. It's a method that is associated with the class as a whole rather than with an instance. Now, that always seemed like an odd choice in an interface because a class implements an interface. So that if you wanted a static method, it made more sense to think about something associated with the class as a whole rather than the interface part of it that's going to be implemented by a wide variety of classes. So the restriction on having static methods on interfaces prior to Java 8 was always kind of a philosophical one. It was just didn't seem like the right abstraction. So the problem with not having static methods in interfaces with that restriction before is that it wound up adding additional classes. We just saw that because I had a collection and I wanted to sort that collection, and in order to find the sort method I had to go to what's often called a utility class called collections with an S. In other words, they wanted to add methods that operated on these collections, but you couldn't add a default or an implemented method into the interface itself, so they made a separate class that consists entirely of static methods, in this case called collections with an S. Now that we have static methods, then the same mechanism is no longer required. You can actually put the static method right in the interface itself. For example, this is a class we're going to look at a lot more in the API later on. This is the interface called stream. Stream produces a sequence of values that are not stored anywhere and are immutable, but that are provided in sequence so that you can do further filtering or processing on them. We'll talk more about that in a different section, but right now I just want to look at stream as an interface. Supports both sequential and parallel aggregate operations, etc. If you scroll down, now in the methods, they show multiple categories of methods inside here. I'm currently looking at all the methods. Normally what we would expect to see are these abstract methods. These are all methods that are required to be implemented by any classes that implement the interface. But we also now have static methods. And these static methods have the keyword static on them and can be used to produce new streams, for example. Like this stream.empty would produce an empty stream, or stream.of would take a variable argument list of generic values. I could say, oh, a stream.of string 1, string 2, strings 3, string 4, and I'd wind up with a stream of strings. And the benefit of having this as a static method in the stream interface is now I don't have to create a separate class just with these sorts of factory methods. We also have generate and iterate, both of which also produce new streams. There's a builder and concat. So in this particular case, all these static methods are essentially factory methods for creating streams, and they were able to add them directly to the stream interface rather than go elsewhere. I'll use those later, but I just wanted to highlight that they exist right now. The thing I do want to talk about now, however, are these so-called default methods. Now, in default methods, I don't want to look at stream at the moment, or rather we will look at stream, but I want to show a different example, and that's the one that I've mentioned multiple times, which is iterable. Here is the iterable interface, which has been around in Java for, well, many years, back since Java 1.5. And in this, we had a single abstract method called iterator, which returns an implementation of the iterator interface. That's another one. That's a method that's an interface for saying that there is an additional element, or testing to see whether there's another element and returning it. In this case, however, they've added a default method called forEach. I'm not worried about this one. I just want to look at the default method called forEach here, which is implemented to say performs the given action for each element of an iterable until all elements have been processed or the action throws an exception. It takes a consumer as an argument. So the argument here says give me a lambda, if you will, some implementation of the consumer interface that has a method that takes one argument and returns void. The beauty of doing this by default, though, is that now all the existing implementations of the iterator interface automatically inherit this. And we saw this before when I was doing my print with the employees. Then here is my for each method being applied to a collection. Well, as it turns out, list implements iterator and therefore has a for each method in it that takes a lambda. In this case, my lambda was the method reference just to print them out. So a default method works out very nicely. Now, of course, the question that comes up is what can I override the default method, and what if I implement multiple interfaces that have the same default method? What happens when I get a conflict? So here's an example of that. This is an interface I created just called company. Nothing complicated. There would be many, many more methods in here. But I put in a single method called getName, which returns the name of the class. The defaults here is the name of the package as well. So I'm just saying I'm returning the company name. Returns a single string, and I'm using the keyword default, which has been in Java for a long time. We just don't normally see it because it shows up in switch case statements, things that we don't see very often in Java. But at any rate, they use the default keyword, and here's getName. Now, if I have an employee, this is a different employee with just first, last, and do work, I also have a default getName, but this one puts together the first name and the last name separated by a space. Obviously, that could be a lot more elaborate. I just wanted an implementation of getName that was different than the implementation in company. So now I have a default getName in company that just returns a string, and an implementation of getName in employee that returns a string that's composed of the first name and the last name together. If I make a class called company employee and implement both interfaces here, both company and employee, now I have a problem. Now let me comment out my own implementation, which then I'll show you to show how you fix this problem, is I immediately introduce an error. And the error is, it says interface company employee inherits unrelated defaults for getName from company and employee. So in other words, it simply doesn't compile. Now the rules are the following. Class overrides interface. So if you ever put the same method in the class it's a default method in the interface, class wins every time. Which is why you wouldn't put a default toString method in an interface, because it would always get overridden by the class object. So there'd be no point. Class always beats interface. Now, what if you have them from multiple interfaces? Well, if one's a child of the other, then child overrides parent, the same way that happens with classes. But if they are not in a parent-child relationship, then as you can see here, the class simply doesn't compile. So in this case, the way you fix the problem is you add your own implementation, because again, class beats interface. So my own getName method returns a string, but what if I want to use the default methods that were in the various interfaces? It turns out you can get at them using the super keyword. So here it says, let's format a string, %s is working for %s, so that here is employee.super.getName. That's going to call the getName method from employee. And here is company.super.getName. That calls the getName method from the company, so that now when I call getName on company employee, I'm going to wind up with employee's name working for company name, and I've resolved the problem. So that's an example of default methods in the interface. Now I have a little demo as well where I use that stream.of, so there's my static method, and convert it to a list. Well, inside a list now, list is an interface, they have added a default method called removeIf, for example. RemoveIf takes as an argument a lambda. This is the simplest form of a lambda. The lambda that removeIf takes, if I look at the documentation, is something called a predicate. A predicate is an expression that returns a Boolean, true or false. So in this case, what I'm saying is take my single argument, that's the number here, and return true if n is less than or equal to 0, return false otherwise. So remove if is a default method added to list that takes a predicate as an argument, and it returns true if any elements are actually removed. So this is basically taking this collection of numbers and saying, were any of, I want to take out all the negative numbers, and that Boolean will be returned to say whether any were removed at all, and I could print them out. And this is, if I run this one, you'll see that, yes, in fact, elements were removed. Didn't format that as well as I might have liked. But regardless, let's take it right here. There we go, that looks a little better. You can see that the static method on the interface was useful, and here is a default method on the interface was useful, and then here is our for each method also on the interface, although it looks like I'm applying it to the collection implements iterable, and iterable is the interface, and everything works fine. So in this case, we use both static and default methods in the interfaces, and they exist throughout the standard library. And you're able to check inside the Java docs to see where they are, especially for the default methods. And you can see, hopefully, how they can become useful in your own development.